Hello and welcome to Visaco's GMAT podcast. My name is Bhaskar. In this episode, we are going to be looking at serious GMAT prep concepts. This is not a strategy session. This is not tips and tricks. We're actually going to be learning certain concepts from the quantitative reasoning section of the GMAT. And then we'll round it up with 3 questions. 1 problem solving and 2 data sufficiency questions that will actually put to test how these concepts that you're going to be learning today will be used or tested in the GMAT context. The answers and solution to those 3 questions will be followed in the next episode's podcast. Before we proceed with what we are going to be doing this week, let's quickly run through the answer to last episode's question. The question last episode was this. For 2 numbers x and y, if we know that x is greater than y, will 2x be always greater than 2y? Yes, certainly, irrespective of what x is, what y is. We are multiplying both sides of the inequality by a positive number 2. Therefore, the inequality will still hold good. So if x is greater than y, then 2x will always be greater than 2y. So what is the concept we are going to be looking this episode? This episode's concept is basically classifications of numbers. Essentially, we are talking about number systems. This is a very elementary concept, but a very, very important one, especially when it comes to cracking the data sufficiency questions. A question could tell you that x is a rational number. It could tell you that x is a real number. So you need to know what is a rational number, what is a real number, how does it make a difference to whether the answer is statement 1 alone is sufficient or you need both the statements. So getting a good handle on classifications of number is a good starting point to start your GMAT preparation. Let's get started. Let's start with number systems. We're going to be starting with natural numbers. Natural numbers are usually denoted by this uppercase letter N. So that stands for natural numbers. What kind of numbers are natural numbers? 1, 2, 3, 4. Positive numbers, full numbers are natural numbers. The next larger set of numbers are what are called as whole numbers, usually represented by the uppercase W. What kind of numbers are whole numbers? Whole numbers include the entire set of natural numbers and it has one additional number, 0. 0 plus the set of natural numbers will give us the set of whole numbers. The next larger set of numbers are what are called as integers. These are usually represented by the uppercase letter Z or Z, standing for the German word Zahlen. What are integers? Integers, as I said, are a larger set, which means that it includes all the numbers that we find in whole numbers. So it's a set of whole numbers plus negative full numbers. So numbers such as minus 10, minus 8, minus 3, minus 2, minus 1, all of these are a part of integers and the whole set of whole numbers starting from 0 all the way up to positive infinity. So negative infinity to positive infinity, all full numbers are a set of integers that we have. The next larger set of numbers. Is there any other numbers other than the integers? Certainly yes. Between 1 and 2, there are numbers such as 1.5 or their fractional equivalent, which is 3 by 2. So fractions or rational numbers is the next larger set of numbers. Let's start with the definition of what a rational number is. Definition of a rational number basically goes this way. Any number which can be expressed in the form p upon q, where p and q are integers such that q is not equal to 0 is called a rational number. I said rational numbers are a larger set over integers, which means that can integers be written in the form of fraction? Yes, integers can be written in the form of fractions with the denominator being equal to 1. So let's say an integer 7 is 7 upon 1. An integer minus 7 is minus 7 upon 1. So rational numbers are basically fractions where p and q are integers and q is not equal to 0. Q not equal to 0 because anything upon 0 is not defined. Now we'll also look at what kind of a decimal expansion will be there for a rational number. Rational numbers when expressed as decimals will be one of these 2 variants. The first variant is the decimal expansion will terminate. Let's start with integers. We know integers are rational numbers. After the decimal point, how many digits do we have? 7 point and there is no other digit after it. You'll say 7.0, you can say 7.00. 00 does not count. How many ever zeros after the decimal point without any significant other digit which is there has no meaning at all. So it terminates immediately after the decimal point. Let's take a 1 upon 4. Its decimal expansion is 0.25. It terminates 2 digits after the decimal point. Let's take something like 1 upon 8 that is equal to 0.125. It terminates 3 digits after the decimal point. So it will be a terminating decimal, which is one possibility for rational numbers. The second possibility is it need not be terminating. It could be going into infinite number of digits. But if it does so, it should be a recurring decimal. Let's take a very simple example. 1 upon 3 is a rational number because it's of the form p by q where both p and q are integers and q is not equal to 0. What's the decimal expansion of 1 upon 3? The decimal expansion of 1 upon 3 is 0.3333. It goes on non-terminating, but it is recurring. So the decimal expansion of rational numbers will be one of these two variants. Either it's going to be terminating, then there's absolutely no issue at all. But if it ends up being non-terminating, then it necessarily will have to be a recurring non-terminating decimal. Talked about rational numbers. Are there numbers which are not rational? And before we end this rational number discussion, how are rational numbers represented? The rational number is usually represented by the uppercase letter Q. There are some numbers which are not rational. Those numbers are called irrational numbers. What kind of numbers are irrational numbers? Let's start with the definition. What is not rational is irrational. What was rational? Rational was a number which could be expressed in the form P by Q, where Q is not equal to 0. So what are irrational numbers? Irrational numbers are numbers which cannot be expressed in the form P by Q, where both P and Q are integers and Q is not equal to 0. Brilliant definition in the sense that it is not rational. So we've given what rational is and we said it is not that. So what can you give? Can we look at some examples for irrational numbers? So figure out what kind of numbers those are. Examples of irrational numbers are square root of 2, square root of 3, cube root of 5. So any pointer for identifying irrational numbers? Typically, if you look at square root of any non-perfect square, cube root of any non-perfect cube, these numbers are essentially irrational numbers. So an irrational number, for example, let's take root 2 and look at how the decimal expansion of that number is. The value of root 2, we typically say is 1.414. We terminate it for our convenience. But actually the value of root 2, if you key it into Google or if you key it into a scientific calculator, you'll realize that it goes on as 1.4142 and it goes non-terminating. And it also is non-recurring. It does not have a pattern the way 1 upon 3 had, or the way, let's say, 1 upon 6 will have. 1 upon 6 is 0.1666. The 6 keeps repeating from the second digit after the decimal point. So root 2 will be both non-terminating and it will not have a pattern and it will be non-recurring. So non-terminating, non-recurring is the property of how the decimal expansion of an irrational number is going to be. Let's look at some special numbers, some very interesting numbers. Pi is an irrational number. I'm not sure if you guys watched this movie Life of Pi. Life of Pi, the guy writes the value of pi starting from 3.14 and he goes on writing to about 50, 60 digits. I don't know how many digits he writes. So the value of pi is non-terminating and it is non-recurring. Pi is an irrational number. Now that I mentioned pi is an irrational number, we quite often write pi to be equal to a 22 by 7. Pi is not equal to 22 by 7. Pi is approximately equal to 22 by 7. 22 by 7 is a rational number. Because 22 by 7 is of the form P upon Q, where both P and Q are integers and Q is not equal to 0. So how can it be irrational? So 22 upon 7 is certainly rational. That is the rational number whose value is closest to the value of pi. So the rational approximation for the irrational number pi is 22 upon 7. So don't think pi is equal to 22 by 7. Pi is approximately equal to 22 by 7. 22 by 7 is rational. Pi is irrational. We know that rational numbers are essentially fractions, which can be written in the form P by Q, where P and Q are integers, Q is not equal to 0. And we also know that irrational numbers cannot be expressed in the form P upon Q. Therefore, there cannot be any element which is common to both these things. What is one is not the other. So, rational numbers and irrational numbers are disjoint sets. There is absolutely no element common to them. Take both these disjoint sets and put it into a larger set, put it inside a larger set. That larger set is what is called as real numbers. So what are real numbers? Real numbers is the collection of all rational numbers and irrational numbers. Is there any other way to define real numbers? Yes. Real numbers are such numbers which when squared will give you an answer which is non-negative. What does that mean? Let's take a few examples and check out. Is 3 a real number? Yes, it's a rational number, it's an integer, it's a natural number, so obviously it's a real number. Square 3, we get an answer which is equal to 9. Is minus 3 a real number? Certainly yes, it's an integer, so anything upwards, it's going to belong to that set, so it belongs to a set of real numbers. Square minus 3, the answer is 9. Square a positive number, square a negative number, you're going to end up with an answer which is a positive number. There's one exception, which is 0. Square 0, you're going to get 0, which is again non-negative. So real numbers are such numbers which when squared are going to give you an answer which is going to be non-negative. So are there numbers which when squared are going to give you an answer which is negative? Yes, those numbers are not real numbers, or they are called imaginary numbers. Square root of, let's say, a minus 2 is an imaginary number. Square this. When you square a square root, the square root goes off. What will you be left with? When you square it, you're going to get an answer which is equal to minus 2. Such numbers are imaginary numbers. From a GMAT perspective, you just don't have to worry about imaginary numbers at all. GMAT restricts the entire discussion and testing only to real numbers. Right? Now, got an idea about the different types of numbers. Like to leave you, before we move on any further into the classification, with this one idea about how we can remember this. Think of a bullseye. Think of a set of concentric circles. The innermost circle will be natural numbers. The next outer circle is whole numbers. The next outer one are integers. The next outer circle will represent rational numbers. Then draw one circle by the side of it, outside of this bullseye circle or the concentric circles. Call that as the irrational numbers. Put both these circles into a larger circle. We'll end up getting the circle that comprises real numbers. Let's look at a little bit more of the classifications which are going to be useful in addressing a lot of questions. Let's start with numbers, what are called as even numbers and odd numbers. Even numbers and odd numbers are subsets of integers. Let's get started there. Right? 4.2 cannot be an even number. Even numbers are subsets of integers. So what are even numbers? Even number is such an integer which, when divided by 2, will leave you a quotient which is an integer and a remainder which is 0, which is this number is perfectly divisible by 2. Example of even numbers: 4 is an even number. 4 upon 2 gives you a quotient which is 2, which is an integer, and the remainder is equal to 0. 10 is an even number. 10 divided by 2 is equal to 5. The quotient is an integer. The remainder is equal to 0. What are odd numbers? Odd numbers are such integers which, when divided by 2, will leave you a remainder which is equal to 1. 3 divided by 2, the quotient is 1, the remainder is 1. So 3 is an odd number. 7 divided by 2, the quotient is 3, which is an integer, but the remainder is 1. So any integer which, when divided by 2, leaves you a remainder of 1 is called an odd integer. Is 0 an odd integer or 0 an even integer? Let's divide 0 by 2 and see what we get. 0 divided by 2, the quotient is 0. So the quotient, is it an integer? Yes. What is the remainder? 0 divided by 2, the remainder is 0. The quotient is an integer, remainder is 0, which means that the number has to be an even number. So 0 is an even integer. So odd integers are integers which will leave a remainder of 1 when divided by 2. Even integers are integers which will leave you a remainder of 0 and a quotient of an integer when divided by 2. 0 is an even integer. Let's also look at one more classification which is going to be very useful. Classifying numbers as positive numbers and negative numbers. Let's say x is a positive number. When you add a positive number to another number, the value of that number goes up. Let's say I'm going to take an example of x to be equal to 1. I'm going to add 1 to 5. Does the value of 5 go up after adding 1 to it? Yes, 5 becomes 6. So you add a number to another number and the value of the original number goes up, then the added number is going to be a positive number. What are negative numbers? Negative numbers are such numbers which, when are added to another number, will bring down the value of that number. Take a case of minus 1. Add minus 1 to 5. When you add minus 1 to 5, the value of 5 becomes 4. If the value of the number decreases, then the given number is a negative number. So you've understood what negative numbers are, what positive numbers are. They need not just be integers. For example, 1.2 is a positive number and minus 3.3 is a negative number. The question that we had for odd and even integers, the same question I'm going to ask in the context of positive and negative numbers. Is 0 a positive number or a negative number? You add 0 to a 5. Does the value of 5 increase or decrease? No, it remains unchanged. So 0 can neither be negative nor be positive. 0 is an even integer. 0 is neither positive nor negative. Let's look at few more interesting results that we need to know and will be very useful in solving questions. Let's look at what happens when we add, subtract two odd numbers or two even numbers, or an odd number and an even number. Sum or difference of two odd numbers is always even. Sum or difference of two even numbers is also always even. So if both the numbers taken are odd or both the numbers taken are even, then the addition or subtraction of those two numbers will always result in an even number. Take an example when in doubt and quickly check out what happens. I'm going to take two odd numbers 1 and 3, add these two, you get a 4, which is even. I'm going to subtract 1 from 3. 3 minus 1, both the numbers are odd. The result is 2, which is even. So both the numbers are odd, add or subtract it, you get an even number as a result. Look at when it comes to two even numbers. 4 and 2 are the two numbers I'm going to take. 4 plus 2 is 6. So added two even numbers. 6 is even. The result is even. I'm going to subtract 2 from 4. 4 minus 2 is a 2. Both the numbers are even. The difference between the two numbers is a 2, which is again an even number. So addition of two odd or subtraction of two odd addition of two even or subtraction of two even will result in an even number. If I add or subtract two numbers, one of which is odd and the other is even, the result is going to be odd. Let's take one even, one odd. 2 is an even number, 1 is an odd number. 2 plus 1 is 3, which is odd. 2 is even, 1 is odd. 2 minus 1 equals 1, which is also odd. So addition or subtraction of two numbers, one of which is odd, one of which is even, is going to result in an odd number. What happens when it comes to multiplication? Multiply any number of odd numbers. All of them, if they are odd, the result is going to be odd. 3 times 5 times 7. 3 times 5, 15. 15 is odd. 3 times 5 times 7. 15 times 7, which is 105, which is also odd. Keep multiplying any number of odd numbers. If you just take only odd numbers and multiply them, the result is going to be an odd number. You take any number of integers that you want and you multiply the entire set with one even number, the net result will be even. What if it is 2 times 3 times 5 times 7? We know that 3 times 5 times 7 was 105. That's an odd number. I multiply the product of 3 odd numbers with just one even number 2. The result is going to be equal to an even number, which is 210. So you might have 100 odd numbers and you might multiply that with one final even number. The product of these 101 numbers will be an even number. So if you have only odd numbers and you multiply them, you're going to get odd number as a result. If you have a mix of numbers and if you find even one such number is an even number, the result is going to be an even number. Let's look at what happens when we multiply positive and negative numbers. Product of two positive numbers is always positive. Product of two negative numbers is also positive. If both are positive, both are negative, the final result, the product, is positive. If one number is positive and one number is negative, the net result is going to be a negative number. We'll do 3 questions, one of which is a problem solving question, and 2 questions which are data sufficiency questions. We'll discuss the answer and the solution in the next episode. Put pen to paper to note down the question right away. Start with the first question. It's a problem solving question. Which of the following numbers is irrational? Right? Quickly recollect what is the definition of irrational numbers, what are pointers to identifying irrational numbers, and basically what is the decimal expansion of an irrational number. So they should quickly run at the back of your mind so that you know we are ready for this question. Answer option A is square root of 20 upon 45. Answer option A, the number is square root of 20 upon 45. The entire fraction is under the root. Answer option B, it's again a fraction. The numerator of the fraction is 7 root 3. The denominator of the fraction is square root of 27. So option B is 7 root 3 upon root 27. Answer option C, it's a fraction. The numerator is 1. The denominator is square root of 64. So the number in answer option C is 1 upon root 64. Answer option D, it's again a fraction. The numerator is 7. The denominator is 3.1. So the number is 7 upon 3.1. Answer option E, it's again a fraction under a square root. Square root of 36 upon 63. The entire fraction 36 upon 63 is under the root. So answer option E is square root of 36 upon 63. Use all the properties we were discussed about rational and irrational numbers. Figure out which among these 5 numbers is an irrational number. Only one number is an irrational number. Let's move on to the second question. This is the data sufficiency question. I presume you know how the data sufficiency questions work. If you're not sure, watch our video on YouTube as to how to solve data sufficiency questions and get a good handle on the 5 different answer options. Our YouTube channel is youtube.com/Wizako, Wizako. Right? Go to the data sufficiency section. There's a 30-minute video which will give you a good starting point to understand how data sufficiency works. Right? Once you got a handle on it, come back to this question. This is the question number 2. The question stem reads as follows. Is the positive number x an integer? I'll repeat the question stem. Is the positive number x an integer is the question. Statement 1 is 5x is an integer. 5 times x is an integer is statement 1. Statement 2 is x upon 5 is an integer. I'll repeat statement 2. It is x upon 5 is an integer. Question number 3 is again a data sufficiency question. I'll start by reading the question stem and then follow it with the 2 statements. The question stem reads as follows. If A, B, and C are non-zero numbers, how many of these 3 numbers are positive numbers? So the last one dealt with whether a number is an integer. Here we are talking about whether numbers are positive numbers or negative numbers. The concepts that you have learnt about classifications of numbers comes of use. I'll repeat the question system again. If A, B, and C are non-zero numbers, how many of these three numbers are positive numbers? Statement 1, A plus B plus C is greater than 0. The sum of these three numbers is positive, is what statement 1 is. Statement 2 is the number of negative numbers is more than the number of positive numbers among these three numbers. Among the three numbers A, B, and C, there are more negative numbers than positive numbers, is what statement 2 is. Right? Run through all these three questions. You can send in your answers through email to us to learn, LEARN, at visaco.com. In the next episode, the episode is going to focus on discussing these three questions in depth. Before you leave, I want you to do two things. One, just youtube.com/visaco. Subscribe to it and turn on notifications. We have a lot of useful videos to help you with your GMAT preparation. Second, you can sign up as a trial user at wzko.in/core, CORE. Right, I'll repeat the URL again, wzko.in/core. Sign up as a trial user, get started with statistics and average, and build momentum to your GMAT preparation. Until next time, stay healthy, stay safe, and stay motivated.